Picking up where we left off, we have problem D here, or example D. We look inside this parenthesis, which is a bracket, and we look inside the bracket and have this parenthesis. So we would do this parenthesis first. 9 minus 4 is 5. So we have 2 bracket 5 plus 2 parenthesis 5 bracket. Now we still need to work inside this bracket. We can't do anything more with this parenthesis. So our operations are addition and multiplication. We do the multiplication first. So we have 2 times the bracket of 5 plus 10. Now we're still working inside this bracket. We have 5 plus 10, which is 15. And 2 times 15 is 30. So that took care of example D. Now we go to example E and F. Now example E, we look inside this parenthesis here. We have this bracket, but we go to this parenthesis. We have an exponent and subtraction. We do the exponent first. So we have 7 plus 3, and then parentheses, 2 to the third power is 8 minus 1. Now, we still have to do inside this bracket, but this parenthesis here first. 8 minus 1 is 7. So we have 7 plus 3. 8 minus 1 is 7. Close our bracket, divided by 4. Now, we look here. Still inside this bracket, we have addition and multiplication. We do the multiplication first. So it's 7 plus 21 divided by 4. Still working inside this bracket. 7 plus 21 is 28 and divided by 4. Now even though this 28 is in the bracket, we cannot do anything else with it. So we're basically left with 28 divided by 4, which is 7. And now we go to F. We have this division problem. We look at the numerator first, then we look at the denominator. Now with our numerator, we have multiplication. These parentheses we can't do anything with. So we have multiplication, addition, and multiplication. We do the multiplication first. Negative 11 times negative 4 is a positive 44. Plus 2 times negative 7. Now in our denominator, because the denominator doesn't affect the numerator now, we could do the operation in our denominator. 7 minus the parenthesis of negative 3 will be 7 plus 3. Because we know this is the opposite of negative 3, which is positive 3. So now we go back to our numerator. We will have 44. We have positive 2 times a negative 7, which will give us a minus 14. And 7 plus 3 is 10. 44 minus 14 is 30, divided by 10, which is 3. Now, we scroll down here to example 5. It says evaluate x squared plus 5x for x is 3. So we substitute in 3 for x. So now we have parenthesis 3 squared plus 5 times the parenthesis 3. These parentheses we cannot do anything with. So we look to our next operation, which is exponents. Parenthesis 3 squared is parenthesis 3 times parenthesis 3, which is positive 9. Now, plus 5 times the parenthesis 3 will give us 15. And 9 plus 15 is 24. Oh, got a little past us there. Need to scroll back up. Okay, now we go here to example 6. Example 6 is a little lengthy, but it tells us to simplify. So we don't have any substitution here. So we still will follow the order of operations. All of these values on the outside of the parenthesis, we cannot do anything with them yet. So we go inside of this bracket, and we could take, first of all, x squared minus 2. They're not like terms, so we cannot do anything with them on the inside. There's no exponents on the outside, so we would take this 7 and multiply by this parenthesis. It would be 7x squared minus 14, and then that would be plus 4. Now I just left it in parentheses, but we could pull that out of the parentheses. So we have 14x squared plus 5 minus the bracket of 7x squared minus 14 plus 4. Now we can combine like terms. This negative 14 and 4 we can combine. So on the outside we have 14x squared plus 5 minus. In the bracket we have 7x squared. This will give us minus 10. Now, you still cannot do anything on the outside of this bracket, but we do have a minus sign in front of this bracket here. So that changes the sign of everything on the inside. So this would be a minus 7x squared and plus 10. Now we combine like terms. We have 14x squared minus 7x squared, which is 7x squared. We have 5 plus 10, which is 15. So this here is our final answer. Okay, now we come to our last problem of section 1.8. It says example 7. In Palo Alto, California, a government agency ordered computer-related companies to contribute to a pool of money to clean up underground water supplies. The companies had stored toxic chemicals in leaking underground containers. The mathematical model C is equal to 200x all over 100 minus x describes the cost, C, in tens of thousands of dollars for removing X% of the contaminants. Find the cost in tens of thousands of dollars for removing 80% of the contaminants. Okay, so this is what we would do. We would take this formula, C is equal to 200x divided by 100 minus x. Now x is the percent. So what we would do is this here. Since we have 80%, it would be 200 times 80 divided by 100 minus 80. Remember, this x automatically represents percent. That's why we do not write the percent sign after 80. So now we multiply. 200 times 80 is 16,000. Divided by 100 minus 80 is 20. Now we could simplify this here. Now remember, we could divide the numerator and denominator by 10. So this will simplify out these zeros. And then we could divide, we will have 1600 divided by 2. Now 1600 divided by 2 is actually 800. Now they want us to find the cost in tens of thousands of dollars. So now if we want to write out what this 800 means, this 800 is actually $8 million. So it's actually $8 million. Because remember, this 800, C stands for thousands, tens of thousands of dollars. So you will have to take this 800 and multiply it by 10,000 in order to get your final answer here, which is $8 million. So that is how much it will cost those companies.